So I'm given the graph of f of x, and I want to find some values from that. So the limit as x approaches -4 of f of x. So if I look up here and I think about as x approaches -4 from the left and from the right, what does the y value approach? Well, I can see that the left and right hand the y value is approaching the same value from the left and right. And it looks like that y value is 2. So the correct answer there is 2. This is saying the second derivative evaluated at x equals +6. So if I look here at +6 and I want to look at the second derivative, well, since that's a linear function, I know the second derivative of a linear function will be 0. It has no concavity. It's not concave up or concave down. So the second derivative will be 0. This is the limit as x approaches 5 from the left. So as x approaches 5 from the left, that would be this way. And what is my y coordinate approaching? It looks like it's approaching 1.5. So the correct answer there is 1.5. And then I want the integral of f of x between -8 and -4. So that would be this region here from -8 to -4. And I can see that that area here is equivalent to this area, and I can actually compute those two areas if I want, but I know that this negative area plus this positive area, it's going to add to 0 because those areas are the same size, but the sign is different. Then f prime of -5.7. So if I look at f at -5.7, that is here somewhere, somewhere here, and I want to look at the derivative there, and so that's just going to be the slope there. So I can just compute the slope of this line, and so the rise, if I go from here to here, the rise is 2 and the run is 2, so the slope of that is 2/2, which is 1. So I'm just looking at the slope of this line here, and so it's up 2/2. For the next one, I want to find, this looks like the definition of derivative evaluated at 3. So this is f prime of -3. And I can see that at x equals -3, that's here, the slope is 0. Okay, so for the next one, I want to do f of 6.8 minus f of 5.1 over 6.8 minus 5.1. And so 6.8, that would be at this point. 5.1 would be at this point. So really all it's asking me to do is compute the slope of that line. And so the slope of that line, I'm not going to use those values because I don't know the value at 6.8 and 5.1, but I can just compute the slope of this line. And so it looks like the slope of this line, if I start at 5.3, I can, every time I go over 1, I'm going up 1/2. So this line has slope 1/2. Then I want the limit as x approaches -2 from the right. So as x approaches -2 from the right, my function is going off to -infinity. And then f prime of 0. So when x equals 0, the derivative there is 0. Then it says, identify a value of x for which f is continuous but not differentiable. So to be continuous but not differentiable, it needs to be continuous. So we don't pick up our pencil, but not differentiable. So the slope from the left and right are not the same value. And so the only place like that is this kind of cusp. So we're looking for like cusps or pointy places on the graph. And so the only place is there, so we'll say x equals -4 is a place where the function is continuous but not differentiable. So then it says the length of a fish as a function of its age can be modeled by that equation. What is the rate at which the length of the fish is changing at 6 years? So what I want to do is compute the derivative of that function and then plug in the value 6. So what is L prime of t? Well, that 32 can just stay there, and then I'll have, well, actually, let's see. Maybe it might be easier for you to see if I factored it out first. So I can say L of t is equal to 32 minus 32 e to the negative 0.37 t. So that might be a little easier for you to see. Now let's take the derivative. L prime of t. Well, the derivative of that constant is 0 minus, and this is a constant multiplied by a function of t, so that 32 is going to stay put. Then I'll have e to the minus 0.37 t, and then the chain rule says I take the derivative of this inside part, so the derivative of negative 0.37 t is negative 0.37. And so there's my derivative function, and then if I want to plug in 6 years, I'll get negative 32 e to the negative 0.37 times 6 times negative 0.37. So I can just use my calculator to compute that. E to the negative 0.37 times 6. And I want to make sure when I put my parentheses in that I have parentheses around this whole thing. So just make sure you do that, times negative 0.37. And I got 1.28, 593, whatever. I'm just going to round to 2 decimals because that seems reasonable. And what are the units of L prime? Well, it is a growth rate, right? So this would be centimeters per year. Because t is in years and L is in centimeters. Next it says a factory produces golf balls at that rate. Exactly how many golf balls were produced in the beginning of week 2 to the end of week 4. And so if we have a rate function, we know that the net change is the integral of the rate. So the integral from 2 to 4 of 120t squared minus 20t plus 950 dt will give us the solution. So that will tell us how much change in golf balls we had over that 2-week period. So we'll get 120t cubed over 3 minus 20t squared over 2 plus 950t, and I'm going to evaluate that from 2 to 4. So if I plug in 4 into that, I get 6,200 minus, if I plug in 2 to that, I get 2,180, and so that gives me 4,020 golf balls.